Today we're doing Leetcode problem 881, boats to save people. You are given an array people where people at index I is the weight of the ith person and an infinite number of boats, where each boat can carry a max weight of limit. Each boat carries at most 2 people at the same time, provided the sum of the weight of those people is at most limit. That's a weird way to say you can only carry up to 2 people and they have to be at the weight limit. So let's go on these examples. This is a perfect example of 2 people who are under the weight limit. When you add 1 and 2 together, they're at 3, so it's actually equal to the weight limit, but it's okay. So we output just one boat. Second example, 3, 2, 2, 1. Our limit is 3. We take 3 boats, 1, 2, 1 and 2. This is 1 boat, 2 is another boat, and then 3 is another boat. So how do we do this problem? One way you can do this problem is by kind of doing like a brute force approach where you consider a weight, and if limit minus that weight has some kind of leftover, right, like 3 minus 1, you loop through the rest of the weights and you try to see if you can take on another weight that still puts you under the weight limit. And that approach might work, given there's a couple of things you have to be careful about there. But either way, that approach is going to be like probably an n² solution in terms of runtime. So let's see if we can think of a better way to do this problem. And I think a better way to do this problem is to actually use 2 pointers and squeeze towards the middle. What I mean by that is, let's do an example. Let's say that we're given people is equal to 5, 4, 2, and 1. Let's say a limit here is 6. You might think, okay, well, here's another approach we can do, right? Is why don't we loop through these people and consider up to the maximum of 2 people at a time? That's a good idea. Let's use that as kind of like a greedy approach, right? If we can only take 2 people at a time, then why don't we take 5, the first person, and we see that we can still have some kind of weight left over. 6 minus 5 is 1. So let's consider 4. Well, 4 is actually too much. It's more than 1, our available capacity. So we would just send 1 person out with this boat. We do 4, and then we see that, hey, 6 minus 4 is 2. We can also consider the second person because we want to, right? We want to minimize the number of boats that we're going to send out. So that would be another boat. Great, now we're at 2 boats. But then we still have this last person, and that's 3 boats. But we can see here that this 5 and this 1 can actually be sent out together, right? And this 4 and this 2, so the actual output is 2, not 3. So did we notice anything here? This is actually a very ideal input, but even if I scramble this, right, like let's say I swap this 1 and this 2, we'll still get the same answer, but let's say they gave it this way. The kind of trick, it's not really a trick, but the idea and approach that we're going to use here is we're going to try and compare with 2 pointers, one at the start and one at the end, and we're going to try and choose the largest value and the smallest value, see if when we add them up together, if we're still at the weight limit. If we are, let's send them out. And by sending them out, we just send 1 boat, and then we move the pointer over here up, we move the pointer over here down. So essentially what you would have is, let's say we have this, we'll sort it, we'll get back that original we saw here, right, assuming it wasn't sorted in the first place. Pointer at 5, pointer at 1, compare them, move it up, pointer at 4, pointer at 2, compare them, move it up and down, and then we'll see that, hey, we're done because they meet each other. So let's just code it up and see if it makes more sense that way. I'm going to sort the input first, create these 2 pointers, and then what I'm going to do is create a result, and after that what we're going to do is while p1 is less than or equal to p2, we have 2 cases, right? If we combined the sum, if combined sum is less than or is equal to our limit, what does that mean? Well, let's zoom out a little bit. That means that we can send out both p1 and this person at p2. So that means that we can increment p1, decrement p2. Else, if the combined sum is not less than or equal to our limit, that means that we are over our capacity, we're over our weight limit. If we're over our weight limit, let's move our p1 pointer up. Send out the person, the largest person, the person with most weight. Let's send them out and keep the pointer at the person with the least weight. When we're done with this, in both of these cases, we're going to increment the number of boats we've sent, right? Because in this case we send out a boat, in this case we also send out a boat. Finally, we just return our result. Let's see if that works. Great. Awesome. Let's talk about the runtime and space complexity here. So, although it's just a simple loop, you might think it's O of n, let's not forget that we sorted our array in the beginning, or the list that they gave us. And so we're bound by this sorting function, which runs in n log n time. So runtime wise, it's n log n. And then space complexity wise, we're actually O of 1. Technically, we didn't use new space, we're just using the list that they gave us, along with a couple of other pointers, but that stays consistent. We know we're always going to use 2 pointers. That's it. So there might be other ways to do this problem, but, well, there definitely are other ways to do this problem, but this was the sort of optimal approach that I came up with. I think when I see problems like these, a really good and helpful approach is that sandwich approach, right, where you use 2 pointers and you kind of move them towards the middle. Thanks, and stay tuned for the next video.